Okay guys, this is a video to show you how to do step 7. So step 7 wants us to determine the coordinate of BC, MP and EC of all the curves. So the curve that I've shown here, it's curve 1. We know from the question paper, we're given the coordinates of all the PIs. So PI 0, these are the coordinates, which are negative 18 312.454 for our y, and our x is given as 33489.623. So in order to determine the coordinates, we need coordinates of the reference point. In this case, our reference point is pi 0. We need the bearing. The bearing from pi 0 to pi 1, it's given as 292 for it's 42 minutes and 44 seconds. The direction from pi 0 to pi 1 is the same as the direction from pi 0 to bc1. What we also need is the distance from pi 0 to bc1. This is given by the total distance from pi 0 to pi 1 minus the tangent length. We know the tangent length is 116. The distance from pi 0 to pi 1, it's given as, we calculated it, we got 4438.002 minus our tangent length. We calculated it and we got this value, which was 116.435. This will give us the new distance of, I'm just getting my calculator. We're gonna have the new distance of minus 116.435. So the distance from pi 0 to bc1 is 4321.565. Remember from survey, when we determine dy is given by the distance sine of the bearing, and then dx is given by the distance cos of the bearing. We know the distance, the one that we just calculated, 4321.565. Sine the bearing is 292.4244. And then we get our answer as 292.4244, and our dy is given as negative 3986.452. So in order to determine the y coordinate of BC, our y BC is given by your y coordinate at pi 0, which was negative 18312.454, plus the change in y dy. Our dy is negative 3986.452. This will give you your y coordinate at bc1. Now our y coordinate at bc1 is negative 22298.9. Now we have to determine our x coordinate. Our change in x is given by the distance, which is 4321.565. Cos of the bearing is 292.4244. So our change in x it's 1168568. So the x coordinate at BC1 is given by the x coordinate at PI0. The x coordinate at PI0 is 33489.623 plus change in x. Our change in x is 1168.568. We're gonna get our new coordinate for B. We're getting our new x coordinate as 35158.19. So the coordinates of BC1, we'll write them like this. Our y coordinate is negative 22298.9, and then our x, we got it as 35158.19. So now we have to calculate the coordinates of MP. I told you from class that in order to determine the bearing from BC to MP, we have to use, let me just use a pen, delta over 4. I told you guys to write it down. So what we do, I showed you a trick on where to determine if you are moving in a clockwise or anti-clockwise direction. You put your pen at BC, you know the bearing from BC to PI1 is still 292. When you move from PC, when you shift your pen, you're moving in an anti-clockwise direction. So what you're gonna do to get the bearing at MP, you're gonna say bearing from BC1 to PI1 minus delta over 4, since we moved in an anti-clockwise direction. The delta that I'm talking about is this delta, this one, the one we calculated, 32. So what you will do, you put that 292, it's gonna be 292 degrees 42 minutes and 44 seconds minus 32, which is the delta, 27.33 seconds divided by 4 to get the bearing from BC1 to MP. So this will give us 292 42 44 minus 32 27 33 all divided by 4, and then you get the new bearing from BC1 to MP, 284 35 and 50. Let me just write as 51 minutes, seconds, not minutes. Now the distance from BC1 to MP1, it's given as the curve length, which is also known as the arc length, divided by 2. Our curve length, we got, what was our curve length? So our arc length for the first curve, it's 226.608. 226.608, we divide it by 2. This will give us the distance from BC1 to MP1. It's going to be 226.608 divided by 2. This is 113.304. We have the bearing. We also have the distance. Your dy is the distance, 113.304. Sine the bearing. The bearing is 384. 35 minutes and 51 seconds. Oh, it's 2 sine 284, 35 minutes and 51 seconds. So your change in y is 113.304 sine 284, 35 minutes 51 seconds, and then you get a dy of negative 109.647. Your dx, so your y coordinate at MP is gonna be your, now we're going back, we're using coordinates of BC. Remember your y coordinate at BC, it's negative 22298.9. You add it, you with y, changing y, you get 6, and then you're gonna have is negative 22298.9 minus 109.6649. You get your new coordinate. Your MP, your y at MP is 22408.55, and then your dx is given by your distance. The same distance is 113.304. Cos of the bearing. The bearing is 284.35 minutes and 51 seconds. So it's 113.304 cos 284.35.51. So your change in y is 28.556. So your y, your x at MP is given by 28556 plus the y coordinate at BC, your x coordinate, your x coordinates plus 35158.19. So your new y coordinate is 35158.19. So your coordinates at MP, it's your x at MP is 35187.35. So you have your coordinates of MP1 and BC1. Now we want to calculate the coordinates of EC. Now we're going back to our curve. We want to determine the bearing from BC to EC. So we're calculating coordinates of EC. So for coordinates of EC, we're going to use our reference point as PI1. We know the distance from PI1 to EC1 is the same as our tangent length. Our tangent length is 116.435. So our bearing is given as it's the same as this one, 260, because this PI1 to PI2 has the same direction as PI1 to EC1. So our bearing is going to be 260 degrees 15 minutes and 11 seconds. So our change in y will be given as 116.435 times the sine of 260 1511. So our change in y will be negative 114.754. The change in x given by 116 cos 260 1511. The change in x, it's negative 19.712. Your EC1 coordinates, you add your change in y to your EC, your PI1 coordinates. So you're gonna add negative 114.754 to negative 22406, and then you get your y coordinate at EC1 as negative 22521.069. You add negative 19.712 to 35, you get your new x coordinate as 35183.536. So you calculated your coordinates of MP1, your BC1, and your EC1, and then you are done. You do the same thing for the other curves. You check whether your curve is a seg or a crest. Is it facing up or down? You check whether when you use delta over 4, are you moving in a clockwise or anti-clockwise direction, but the steps are the same. Thank you.